Great. Thank you, Paula. My name is Erica Oriens. I'm the Executive Director of the Center for Student Success at the Michigan Community College Association. Today, I'm a poor substitute for Jenny Shanker, who I work with and who has been leading this math work in Michigan. And as at her request, and especially a lot of folks who have been engaged in this work across the state, the Dana Center was kind enough to pull together some webinars to really focus on co-requisite supports in the three pathways. So today is the first webinar focusing on the pathway to calculus and talking about some of those supports that we can provide students in their pathway to calculus. There will be two more webinars, one focusing on statistics and one focusing on quantitative reasoning. So we're happy that we are able to provide these, and especially happy that the Dana Center is able to help us out with this. At the end of this, I think we'll be, since these are being recorded, we'll be able to post these and then send them out through our communication channels so that folks can stay updated. Or if you can't view it today, if you have colleagues who want to view the webinar, they're able to do that as well. So with that, Paula, I'll turn it back over to you.
So hello, I'm the Systems Implementation Lead at the Dana Center. I may have met some of you at the convening in November. In this webinar, we have Lance Phillips from Tulsa Community College, and we have Tammy Randolph and Dan Daly from Southeast Missouri State University. And what we're going to do in this webinar, they're both going to talk about their structures, some things that happen in their classroom, some of the planning issues that have come up. You will hear that both stories are unique. In each presentation, as they're talking through them, you will notice that you have a chat button. So if you want to click chat and ask any questions, you can kind of keep record of any kind of questions here. And that way, whenever we stop, so after Lance gives his, we'll stop and you'll have the opportunity to talk through some questions with him. And then same thing with Tammy and Dan. After they give their presentation, you'll have a chance to stop and ask questions. And then at the end, we'll just open it up to whatever questions you want to ask them. We will let it be a free-for-all, and we'll do our best to answer them. And any questions that we can't answer, we have them, we'll keep track of them and try to follow up with you on these questions. So with that, I am in control of the PowerPoint, so you'll hear them say next. If I lost control, then I wouldn't have access to chat and anything else. So you'll hear them say next as they go through their presentation because I'm controlling the PowerPoint. So Lance, you're up.
Good afternoon. My name is Lance Phillips. I'm Associate Professor of Mathematics at Tulsa Community College. I'll give you a little background on the school and kind of go through quickly that part of it. We're the third largest institution of higher learning in Oklahoma and the #1 provider for transfer students to our two big land-grant colleges. We have an unduplicated student population, about 24,000, about 17,000 full-time equivalent in our 2016-2017 academic year, which is the last one we have measures for. Next. How we got to where we are now is we had both some external and some internal influences going on. External, our governor of Oklahoma signed an agreement with the Dana Center and Complete College America that all the state institutions in the state of Oklahoma would adopt a co-requisite model and at least two pathways for college level mathematics within the degree programs. And the state regents, which govern all higher education in Oklahoma, convened a Math Success Initiative Task Force, of which I was the representative for our school. All 26 schools in the state sent a representative to that. Internally, our college had came off Achieving the Dream with a mindset of changing everything based on data. We had created a developmental redesign team that spent 3 years redesigning our developmental math structure. Oklahoma is not a adult basic education state. It's an open access, so anybody who has completed their 18th year can enroll in college without having any other credentials. And so you don't even have to have an ACT. We get students who have never taken a math course in their life. So we actually, in our redesign, had proposed a fourth tier of developmental. We had the typical three, basic math and introductory algebra and intermediate algebra, then leading on to the college algebra. During that time, we also, our president adopted or signed an agreement with the American Association of Community Colleges to adopt their guided pathways, which actually benefited us that we were doing all these at the same time. And in that, we also had a nice restructuring of our administrative things, adopting faculty department chairs and moving from a dean at each campus to a dean by college. We have 4 major campuses across the city of Tulsa, and really changing everything at the college all at once. Next. The pathway we had for math offerings at TCC prior to adapting the new math pathways in the co-requisite model is that top corner you see that's rather convoluted. Students can come in at various places and take various paths to get to nowhere for the most part, but all paths tended to lead to college algebra, with a small exception of some education majors going into a math functions or critical reasoning course, and a small part of our non-transferable degree, our associate's applied sciences, going into technical math. You can see the bottom part represents pretty much an exact model of the Texas model of to the calculus and pre-calculus pathways. We chose 2 for our initial offerings. We're looking at a statistical pathway yet and a modeling pathway that our 2 big major institutions want. Again, because we are a open access state, we still have a Foundations 1 level for our very lowest placing students. We're looking at that being about 20% right now. We're trying to get it down to even lesser than that of our students who are not ready for college level math. Next. So the question becomes, as we look at this, the same questions that everybody has, questions of rigor. Is it, these new offerings, are they as rigorous as college algebra? And my response has always been, and I was a proponent of this long before we did it, my wife teaches biology. And in Oklahoma, depending on whether you're taking a major that requires biology, they have a biology for majors and a biology for non-majors. They're equally rigorous, but they each have a different desired outcome. And so adopting the different pathways isn't changing or diminishing the rigor. A lot of math faculty particularly thinks that calculus is the only math class that is reasonable for students to have. And that's not a reasonable thing, since most students don't require calculus in their degree plans. So yes, the rigor is appropriate. It's applicable to the degree program, and it's timely. It happens when they need it, as they need it. One of the big issues we had in advising was, and as we talked to the other colleges and states that had done this before us, the reluctance for people to abandon the college algebra enrollment, for advisors to stop advising students to take that path, even if it was designated differently. And so one of the things that we did is we changed the name. We no longer have college algebra on the books. We call what is now our STEM pathway math pre-calculus. And so if you're taking a course of study that requires calculus, whether it be business calculus or STEM calculus, you now enter the pre-calculus pathway. If your degree plan doesn't require calculus, then right now that pathway is a quantitative reasoning pathway for our students. It all started, we got the notification from our legislatures in January of 2016 that the mandates had been agreed to and given to us, and we were at scale with the new co-requisite courses and the new courses as well, the new pathways, for fall of last year. So just over a year in getting it done. A lot of that required close collaboration with, and we maintained, our state regents maintained that task force where we met regularly with Dana Center and Complete College America advisors and with all the other members from the state institutions to make sure that what we were all doing was on the same page, that everything that we did at TCC was going to be transferable to the four-year institutions that our students are leaving TCC to go to. Another big issue for us was faculty development, in that none of us had ever taught a quantitative reasoning course before. It wasn't on our books. And so we had to not only develop the course, but develop a co-requisite for that course and teach all of our teachers how to teach the course. And so that was a lot to happen in that short year and a half so time frame, but we got it done. And the second major issue was placement. Along with all the other changes, of course, we had been using the Compass test, and Compass went away. And so we had to adopt the new AccuPlacer. But we immediately ran into problems in that the AccuPlacer does not and has never really tested for algebraic-based reasoning, not for numeracy, the quantitative reasoning. And so it wasn't a good, useful tool in placing students into the new quantitative reasoning course. Of course, neither is the ACT. It's the same. It's only really testing for abilities in the algebraic thing. So we had to adopt then we chose to adopt the next gen of the AccuPlacer, which had not been normalized. And so we brought in, and at the same time, we brought in some multiple measures and some initiatives that we didn't allow students to retest without taking some mandatory test prep, so that they weren't just coming in, going day after day to retest without really doing anything other than testing to prepare them for the math. And through a study we had done, we found that 67% of our student population place into one level or more of developmental studies. And those that were placing in all three, developmental reading, writing, and math, if they took the test on the same day, about 66% of them placed lower on the reading and writing side than they would if they took them at separate times. And so we finally got the college degree and mandate now that if students are having to take placement tests in both math and either reading and or writing, they have to take those on different days. And we do see a much more accurate placement of our students by splitting those test days, a very simple thing. Next. Okay, some of the steps that we went through, of course, choosing the math course that we wanted to get started in. As we were getting started, really all we knew was college algebra, and looking at the various forms out there of the pathways. The other two, of course, are quantitative reasoning and statistical reasoning, or StatWay. Because in Oklahoma we had not yet resolved our credit-bearing statistics course for our higher institutions, our four-year colleges still requires college algebra as a prerequisite. We did not want to choose it as a pathway where it had a different path course as a prerequisite. So we've held off on going the StatWay model until it's resolved what that 1000 level or that gateway level statistics class would look like. And so we chose the quantitative reasoning and the pre-calculus or the STEM pathway. Once we did that, we started in two avenues. First of all, every one of the math faculty had to serve on one of the committees, one of the task force, either designing the quantitative reasoning course, redesigning the college algebra course into the new pre-calculus course, serving with me on the implementation team. And then those teams had to not only choose and design the curriculum, the platform, and all that, they also had to design the training for all the other faculty who would be teaching those courses, including the adjunct or part-time faculty, which is about 67% of our classes are taught by part-time faculty. As they chose the platform, we did a pilot in the spring of 2016 17 in which we took all of the major publications, so all the major publishing houses, their platforms, and tried them and met regularly to talk about how the students were responding to the different platforms, how we liked the different textbooks that those publishers recommended, just what we thought in general, because our goal was that all 4 campuses, everybody taking a math class at TCC would be working in the same book, regardless of where they went. That made it easy because there's only about 20 minutes between our campuses, and so students might be in my campus in the morning and one of the other campuses in the afternoon. They often bounce around from campus to campus where different programs are offered. And a lot of our faculty, our part-time faculty, teach on multiple campuses. And as it was, all 4 campuses had a different text and a different platform, and so a part-time teacher teaching the same class for our college could go to 4 different campuses and have to have 4 different preps using 4 different platforms, 4 different texts. And so we wanted to go to a common text across the board. And so we did that, and by doing so, we're able to negotiate a better price for our students in using that text, since we could commit to every one of the students at TCC using that platform. After we created the classes, we started having to publicize. I mean, we had to get the class established in our catalog, had to put it in banner, had to start working with our high school support liaison to identify, that this is the way things are now, from placement on up, start preparing your students, because it was a culture shock to our incoming freshmen right out of high school that had grown up preparing themselves for college algebra, now to find that college algebra is not there anymore. We chose, after our pilots also, that we had to choose between either the co-requisite with a commingled or a cohort model. We liked, after we tried both in their initial trials, we chose the commingled, and really both groups benefited in our experience and are benefiting from that. We had to separate our classrooms. We have the co-requisite course taught either immediately before or immediately after the college level course, and what we were finding was that the students enrolled only in the college level were showing up or staying for the co-requisite class, because they saw how much better those students were prepared and how much better they were doing. In fact, there's no discernible in our first 2 semesters. Of course, only 1 at scale, but we had 9 pilots in the first semester in spring. The non-college level students fared as well, not statistically different at least, than the college level students. That they were completing their college math the same as the college level students were through that preparation. So the model was working for us, and some of the students were choosing to try to take advantage of that, and that created a problem. So we had to switch classrooms, which of course created its own problem. Then we had to dedicate a classroom after a classroom. I used to have a single classroom that was assigned to me. I had all my manipulatives, everything in that classroom, and now I have to carry them from building to building and class to class because we have to move classrooms. So that it's not without some pains. That got us into the facility support. One of the initiatives we did for that lowest level, our Foundations 1, is we instituted a math path, what we called it, that's 4 weeks of intense instruction that's online based, mastery based, using the Pearson My Math Lab. And then after 4 weeks, those students retest, and about 50% of them move into the Foundations 2. And so students who a year ago would have been on a pathway that would have taken them 4 semesters to complete, we now have our first contingent of students who are completing their college level math in the first academic year. But that required classrooms with computer support. And so again, there were facilities issues that had to be resolved. And then the logistics of the instructor load. We looked at co-teaching, but we've got 4 different campuses. On any given day, we might have a fire drill during one of those classes that would set it off the schedule. In Oklahoma here, we get a lot of weather-related issues, tornadoes, ice storms, and oftentimes they'll close the campus until 10 o'clock in the morning, which means our typical schedule, our major priority schedule time is 9:30 and 11 o'clock. Those are our 2 biggest hours of student enrollment. And so the 9:30 class would be canceled for the weather, but the 11 o'clock class would still happen. And so that co-teaching just created a logistics nightmare. We chose to go with a single teacher for both the co-requisite or the developmental and the college level math course. Of course, that created a problem in that the majority of our non-college level courses were taught by adjunct instructors who weren't credentialed to teach the college level course. And now with those courses being paired in the co-requisite, they had to be able to teach both the developmental and the college level course, which meant that everybody teaching that co-requisite course had to be able or credentialed to teach the college level course, which meant some of our full-time faculty had to start teaching a developmental course, which they hadn't in the past and didn't want to. And we had to really adjust the schedules for the adjuncts that we had that were credentialed to teach, and there weren't that many. And so even going with the paired load, if they were teaching a co-requisite course and the college level course, that made them exceed the number of allowable hours for a adjunct instructor in an academic year. And so we had to get special compensation to allow those few instructors who were credentialed to teach both to actually teach an overload class as an adjunct. And the last major issue that we had to cover was the grading structure, because we do not offer that co-requisite course as a standalone course. It is only paired with the college level course and only taught in the commingled manner. It didn't make sense to have a student earn a passing grade in that who failed the college level course, because its sole purpose was for them to succeed in the college level course, which meant if they couldn't pass the college level course while having that support, the odds of them passing the college level course without it was slim. And so we chose that if they passed the college level course, they would pass the co-requisite course. If they failed it, they failed them both, which made it high stakes for the students, because we went with a 3-and-3 model. Each, the co-requisite and the college level course, are 3 credit hours, which meant an average student taking full-time enrollment at 12 credit hours had half of their load engaged in that one math course, which meant, of course, if they failed it, they dropped below their satisfactory academic progress requirement of the federal financial aid of 67% to 50%, and really put their financial aid and their ability to continue on in college at jeopardy. And it really has helped, because we've explained and try great lengths to explain to the students how much this one class or that para class means to them and how much they need to place an emphasis on it. And because it's half of their load, there's fewer other classes distracting them from doing the math. And so, yes, it made the math class a high stakes class for them, but we're seeing an advanced success in that. And we're seeing a lot of students now who had that opportunity to stop out or drop out, being one level below college level, to completing that college level in that first academic year, or in many times the first semester. Next.
Okay, and Lance, before you leave the slide, there's a question in the chat box. Can you describe the training for the high school teachers and how did they react?
The high school teachers were very enthusiastic about it because they see a lot of their students. Oklahoma bases their support of our public institutions on the remediation rates that they get dinged if their students are coming to the institutions of higher learning and having to be remediated. By pairing these and allowing students to go right into their college level math course that first semester while getting the co-requisite instruction, it was a godsend to those public institutions, because now they don't have to show those students as being remediated. They're getting their college level math in that first academic year.
Thank you.
So can I ask a follow-up question, Paula?
Yes.
So is the co-requisite course, Lance, in Oklahoma, you don't consider that to be a developmental course?
It is, but because the way we measure, if they're able to complete the college level class in that first academic year.
I see. Okay. Thank you.
Now we want to open it up to anybody else on the call who would like to ask Lance some more specifics about their model, how they teach the courses, or anything else before we move on to the next presenter. And you may type it in your chat if you don't have your sound, but if you don't have your microphone on. And then we'll come back at the end too, so you might want to hear them both, and you have questions to both of them at the end too. Just kind of keep record of your questions you have. Okay, I thank you, Lance. We will pass it over to Dr. Dan Daly from Southeast Missouri State University. And same thing, Dan and Tammy is also, Dr. Tammy Randolph is also supporting him in this call. So whenever you want to move to the next slide, just tell me next. Can y'all hear me? Are y'all on the line? I know they're on the line.
Unmute. Can you hear us now?
Oh, yes, there you go.
Okay, there we go.
I had me worried there for a minute. I was like, oh, no.
Right, yeah.
I'm late and you can't hear me.
Okay.
All right, I don't know. Tammy, would you like to say anything first?
I am here to support Dan. I'm the former chairperson of the mathematics department, now sitting as interim dean, and Dan is sitting in the math department. So if anybody has questions about structure, I can answer those later. Dan's been involved from the beginning of this process. So some of you heard me when I came up to speak to the state about some of the processes we were going through, but I figured Dan, who'd been involved in this course, could more readily answer those than me pretending I know the answers when I don't teach this course. So I brought the expert with me today, so I'm going to stand back here and make rabbit ears for him and go on down the road. But feel free to give us chat messages or ask us questions, because we want to share what we know.
All right, so I'm not here actually to pretend to be an expert. I have been involved with a course called MA 129, College Algebra with Integrated Review at Southeast. And this is a course that we attempted to integrate intermediate algebra and college algebra. And so I'm here to tell you a little bit about that. You know, I am here kind of to give you the nuts and bolts of what we did with this particular course, and to answer any questions about what we've done, and I can tell you, you know, what we've done thus far and where we're headed with it. So back in, I want to say, fall of 16, I believe, my colleague Lori Overman and I were charged with coming up with a course to co-rec with college algebra, traditional college algebra. And we wanted somebody who could enter this course with an ACT between 15 and 21. So they wouldn't place into the standard college algebra course, but they could be successful and have a college algebra credit at the end of one semester. We have suggested standards for the state as to what should be in this college algebra course, and we need to have enough intermediate algebra to supplement this college algebra to make sure that, you know, they're successful with the more advanced topics. Next. So Lori and I kind of looked at each other and were like, how is this going to happen? How can we get a course that fits these these goals, because taking someone with a 15 to 21 ACT and getting them prepared to be successful in college algebra is not an easy task. So the things that we wanted, so here was our wish list. If this is going to happen, of course we want a rigorous course, because if anybody is taking this course, we want them to be successful in their courses after this. Starting in fall, this course is actually being renamed to Pre-Calculus A with integrated reviews. So the students taking this course, it is the expectation that they are going on to calculus. So the people in this course should have a specific direction in mind. So we want it to be rigorous. We actually want it to be in a computer classroom, not a computer lab. So we've taught some other courses we've used in the past. We've used courses based on ALEKS. We've used courses based on Pearson, MyLabs Plus, and MyMathLab. But we really actually wanted to try to emphasize a classroom, and we wanted to also emphasize high interaction, and we wanted time, because in order to talk about intermediate algebra and to make sure that they get the college algebra, we need some time to really discuss those topics and get them engaged in those topics. Next. So here was our philosophy. So instead of taking a course that was 3 credits and then tagging on say a co-requisite lab or something to that effect, we decided to integrate the 2 courses together. So in fact, combine the intermediate algebra topics and the college algebra topics, but not really to distinguish when we were talking about a specific intermediate algebra topic versus a specific college algebra topic. And our overwhelming theme of this is really to tell the story of a family of functions, of families of functions, and to really integrate the idea of a function from the get-go, and then review some of the functions that are necessary in intermediate algebra, and then to do some of the more, and then to do the more advanced topics that are part and parcel of college algebra. So here's kind of the nuts and bolts of what we did with regards to topics. Well, to start with linear functions, and then move up to polynomial functions, work with, graphing these. And the polynomial functions, we're going to talk about, adding, subtracting, multiplying, dividing first, which is part of intermediate algebra. And then we'll move on to solving polynomial equations, solving quadratic equations. We do include some radicals there and some complex numbers so that we can solve quadratic equations in their entirety. And then move on to graphing, graphing and zeros of polynomials. So we try to wrap up all of the material on polynomial functions and its associated prerequisite material before we move on to rational functions and rational expressions. And then tell kind of the story about rational expressions and rational functions. How do you add, subtract, multiply, divide those expressions and functions, and then go on and do some of the more advanced algebra with, graphing them, talking about, domains and ranges and that type of stuff. And we move through, then talking about radical functions, piecewise inverse functions, function composition, exponential logarithmic functions, sequences and series. But our goal was really to talk about a family of functions. So I've got a couple of questions here. How many credits is MA 529? It is 5 hours. And I'll get similar to the logistics here in a second, but it is a 5-hour course. We do try to work with multiple representations. So another question, we do working in tables, graphs, equations, and trying to work with word problems. And we try to spend a lot of class time, not just in lecture, but also trying to give them worksheets, have them work in groups. One advantage that we have at our institution is a lot of our classrooms, we actually have chalkboards all the way around the room. So it actually makes it easy for us, or easy for me, to tell them, okay, I'm going to give you a bunch of problems. I want you to break up into groups of 3 or 4, and the boards are yours. So I want you to, go to the boards, and then I can kind of walk around and talk to people about how they're doing. Next. So here's that logistics. So it's a 5 credit hour course. It meets 75 minutes, Monday, Tuesday, Wednesday, Thursday. Right now, the text for this course was Algebra for College Students by Lyle Hornsby and McGinnis.
Do you want to talk about why it's only 4 days a week instead of 5?
Oh, yes.
I'm the voiceover, so sorry.
So a reminder, my reminder over here, why it actually meets 4 days instead of 5 is because, like Lance, we have some satellite campuses that meet. We have actually 2 satellite campuses now, or will in the fall. And those satellite campuses only meet, those buildings are only open Monday through Thursday, whereas the main campus is open Monday through Friday. And so if we were to, for consistency, some of our courses are taught ITV, interactive TV, where one professor on campus actually has a section on campus and then broadcasts that to sections off campus. Some of our courses actually have a separate instructor that goes down to the satellite campuses and actually teaches a class face-to-face. Face-to-face. And we have this 75 minutes Monday, Tuesday, Wednesday, Thursday to try to be consistent. If we have, one professor teaching it on campus, one professor teaching it off campus, one of the satellite campuses, we can try to remain as consistent as we can and not have, the on-campus class meets 5 days a week, the off-campus section meets 4 days a week, and trying to maintain consistency there is kind of a headache. So that's the motivation for the 4 day a week schedule. So I mentioned the text. The text is mostly enough for what we need, but we still do have to supplement, particularly with some of the graphing, particularly rational functions and exponential functions and logs. We do have to do some supplementation with that. I can get into that a little bit later on. Right now, in terms of homework, right now it's set up through Pearson, MyLabs Plus, with some supplemental pencil and paper homeworks, particularly with the aforementioned graphing. One of the things that Lori Overman and I talked about was, graphing on computer is one of the things we particularly didn't like, and there's nothing quite like, making them, at least in groups in class or somehow getting them to do this, drawing these on paper before they have to do it, say, on an exam. Okay. The way we have structured it is Thursdays are quiz days. They're guaranteed a quiz, 15 to 25 minutes over the previous week's material. They have 4 exams and a comprehensive final. And our college algebra course, which is MA 134, they give the same final. They have a common final. We give exactly that same final. So, if they pass the same final that the college algebra folks take, then they have the same credential as the college algebra folks. And our goal is, in class, I'm a big proponent of IBL, inquiry-based learning. I know the Dana Center at UT Austin has, like Mike Starbird and folks like that. And I, try to take some of his messages to heart of, yes, you want to, maybe lecture a little bit, but you also want to give them some opportunity to try things out in class and get some feedback from your instructor. And then the computer homework really is homework. It's not, kind of like an Emporium model where they actually do work in class on the computers. The goal is to get them talking in class. And part of that too, getting them to talk in class and form groups in class, I think forms a really nice support structure for the students, because, if they're together working on stuff outside of or in class, I've kind of found that those students, some students really kind of hit it off, and they might, go home and form study groups outside of class. And then, they've got a support structure. They've got people to work with on homework. They've got people to work with, studying for exams. And they don't feel, maybe, some of them don't feel quite as overwhelmed or as alone in the class. So next. So just to give you an example, of what I said in terms of integrating material, here's a typical week as we are talking about polynomials. We do have to reorder sections in the book, so we can't really work our way linearly through a textbook. So it did require some work to go through and say, I want to do these particular topics, in polynomials here, and then what's the next appropriate topic in terms of polynomials or rational functions, to kind of group it all in one whole. So, this week starts out, we had been talking about solving polynomial equations. So we talk about completing the square, we talk about the quadratic formula, and then we spend a day and a half on graphing quadratics, just quadratics, and then also do some polynomial long division. So you can see some of that's college algebra, some of that's intermediate algebra. The polynomial long division is an intermediate algebra topic. And then the last day of the week, they have a quiz, and we start to talk about zeros. So remainder theorem, factor theorem, and that goes into the next week. We don't just spend one day on that. They get multiple days. So that's what a typical week kind of looks like for us in here. Next.
Quick question before you move on. Do you have a calendar of your whole semester laid out like this, or did you?
I do. I have a syllabus. I'd be happy to share that with anybody. I've got a full table of what, this came from a syllabus from last semester, but I'd be happy to share the whole syllabus with anybody who would like.
And that's also part of the training. Talk about the training.
And that's also, we do give this. So we do train anybody who teaches this course. The people who teach this course are selected specifically. There's a lot of buy-in to the philosophy of this course, and we create the schedule and say, this is how we're going to do it. These are the sections we're going to do on any particular day, and you have to be really willing to buy into this, being willing to be active in class, high interaction, and kind of integrate. Yes, the beginning of the semester is more intermediate algebra. The last half of the semester is mostly college algebra, but it's not a 50-50 split. It's not true that the first 8 weeks are intermediate algebra and the second 8 weeks are college algebra. They're, interchanged. They're very much integrated. The next course in this sequence, so this would give you a college algebra or a first pre-calculus course. So you would go from here into generally a trigonometry course. That would be your next course after this. Okay. Okay. So here are some other things in addition that we do to provide a support structure for these students. All of our faculty actually hold at least one office hour in a computer lab. So the students do have computer homework, but like I said, it's homework. It's not something they do in class. So we do have computer labs. We have math learning centers that have computers in them, and our faculty do hold at least one office hour. Some hold more. We ask at least one. In addition, before every exam, we offer 2 exam review sessions outside of class. And say, the exam is on Thursday, we're going to hold 1 exam review session on Tuesday, we're going to hold 1 review session on Wednesday. And then you guys can, you may come if you want, you can stay as long as you want. You don't have to stay the whole hour. You can come to both if you want. It's totally up to you how much time you go or how much time you don't go. But it's there for you if you want it. So I actually already mentioned the math learning centers. So math learning centers, we actually have 2 computer labs that are open to students generally the entire day. Those are staffed by sometimes with faculty. Like I said, faculty hold at least one office hour in the lab. When faculty are not there, we have our graduate students. We have some undergraduate math majors also in the lab. And usually always we have at least two people in that lab to provide help for anybody who comes in. The other thing that we have is not through the math department, but actually through University Tutorial Services. We have what's called supplemental instruction. And that's actually done through people who have either taken college algebra or taken this class in the past. It's a student who actually runs a review session or homework help sessions for students who are currently in the class. So we've got a lot of different things that we put together to support the students in this class. I see a couple of questions, and I will answer those in a quick second. One other thing I want to mention, and I had something else I wanted to mention, and it just went out of my head, so as soon as I remember what that was, I will say it. Let me answer the questions then. So question, does MA 129 replace all of the developmental ed courses? The answer is no. There is one course that we have previous to this called Basic Math Skills, and that is for somebody who has an ACT of 14 or below. So if you have an ACT of 14 or below, you would be placed into that course, and if you pass that course, then you could come into this one. But that is pretty much it. There is one course before this one if your ACT is particularly low. And I have another question. Does either school have info about how students do that go on to calculus? For us, this is kind of a brand new course, so we're still, we don't have a lot of data on it yet. Be happy to share that maybe in a semester or two, but I don't have a lot of data. I don't know about Lance. If Lance wants to say anything about that question now or wait till the end. Or
for our students that go on to calculus, only about 12% of our students who in the past, of course, we're just in the first semester now where they have completed the co-requisite model and going on. But traditionally, only about 12% of our students who take college algebra ever enroll in Calc 1. And they succeeded about the same rate, about 65% success rate, about the same rate as those who enroll straight into Calculus 1 without having to take any of the prerequisite courses.
Okay, next. So here's some general observations that I have from teaching this course. I have seen better quiz scores, and than what I saw when I taught intermediate algebra. So better quiz scores and actually better exam scores too. This is a very challenging course for every student involved. And one of the things that I think is important is to always be, a cheerleader for them, to always keep reminding them of the hard work necessary to succeed every day. Particularly because they're intermediate algebra students, they don't necessarily have the study skills or the soft skills to really be successful as a college student. So, I'm always in there trying to remind them, this class is not a sprint. This course is a marathon. And, just because you were successful on exam 1, that does not guarantee success on exam 2, exam 3, exam 4. So you've got to keep going. You can't rest. But the reward is if you are, if you're going to succeed, you've got to be here every day. You have got to be putting in the work every day. And that's something that I think is important to remind them, as I say on the slide, every day. And that's just something that you just have to keep repeating with them. I think, comparing attendance to our intermediate algebra course, just our straight intermediate algebra course and this course, I think it's still kind of an issue. I think it's less of an issue, but I still think it's something that, we still need to kind of work on. I think keeping them active in class is a key component of keeping them attending. I think attendance really becomes an issue in here around midterms. about mid-semester, and that's when particularly, these folks who have, placed into intermediate algebra, these are really folks who placed into intermediate algebra, had problems just, being a student. And that's, we're trying to put as much support structure in place as we can, but keeping them coming to class and keeping them, not just this class, but I think coming to class in general, still can be an issue for some of them. I really, really like how we've organized the material. This to me is, I think, a really nice way of doing it because, in intermediate algebra, you talk about polynomials, you talk about some topics in polynomials. In college algebra, you talk about some more topics in polynomials. In intermediate algebra, you talk about some topics in rational expressions, how do you add, subtract, multiply, divide. College algebra, you talk about graphing them and, some more advanced topics, maybe some more word problems or advanced word problems. And in this class, we can kind of do all of those as one packet. And I really like that. And so, we can talk about, polynomial long division. How do you divide polynomials? And then we can go straight into saying, let's use this tool to analyze the zeros of a polynomial function. And that I really, really like because, it kind of helps maybe them connect some dots between the two. Next. So here's a couple of comments I have from the couple of times, I taught this class in spring of 2017. I taught this class in fall of 2017. And here are a couple of comments that I got from the students. Lots of examples, notes, and interactive atmosphere. They felt engaged. This class is a lot of homework. There's a lot of work to do in class. There's a lot of work to do outside of class. They did note, to cover the material and to review the material that we need. It's a very fast-paced course, but you have to take the course day by day. And students really liked to be able to go to the boards and work on problems themselves. And I think particularly when they went in groups, they felt less that I was looking just at one particular student and was judging them, that either they had to be right or they had to be wrong. But if they were in groups, then they were a little bit more free to make mistakes and freer to if they did something wrong, one of them could say, oh, well, that wasn't my fault, that was this guy's fault. But they were able to, maybe be a little bit more relaxed and have maybe a little bit more fun doing it. Next. So here are at least my conclusions thus far, what I generally think about our structure. It's a challenging course to teach, and it's a challenging course to take. The students have to be motivated. They have to be willing to work very hard to be in here. But when they get in here, the course, I think, has a different dynamic than just a straight intermediate algebra course. The students I've had in an intermediate algebra course, on day one, they're not happy to be in a developmental course. I've had students that say, I had this in a previous course, they didn't pass it, they're in it again. There is not a, generally on day one, they're not happy to be in there. In this class, they seem to be happier because, it's, there's developmental material, but, the credential they get at the end is college algebra or pre-calculus, or in the fall, this will be a pre-calculus course. We will rename it. And just the fact that they're, there's at least the sense that they're being treated a little bit more as college students and not developmental students. I think that's just, as part of the marketing, if you will, helpful to them, just psychologically beneficial. One other thing that I think is really important in order to do this and to be successful doing this, faculty have to buy into the philosophy of the course. And I don't necessarily have the magic answer or the key to making faculty buy into it. You know, I think the people who have taught it thus far have been very specially selected to do this. You know, they have to be willing to buy in, and they have to be willing to put in the time, because this is, you know, different than just teaching a regular college algebra course, definitely. I see a question here for both presenters. Is the enrollment cap the same for the co-rec and the non-co-rec course? The enrollment cap for this course, the MA 129, is smaller actually than it is for the college algebra course. This course, generally we trying to cap at 25 to ensure that interactivity. The non-co-rec course, the college algebra, the straight college algebra course, is actually a 60-person cap. So that's how it is for us. I don't know, Lance, if you want to weigh in on that.
Certainly, we've got it better than you. Our college algebra is capped at 30, and by state law, we charge students an extra fee for being in a developmental level course that caps it at 20, and the extra fee supposedly is to have the lower enrollment student to teacher ratio. And so our commingled course still being capped at 30 means that we'll close the course to college level enrollment once we have 10 college level students in there, until we get at least 10 college or 10 of the co-requisite students in, and then we'll open it up so that it can feel past that make rate with either the cohort or the college level.
Next. And we're here for questions.
Thank you. So any last questions to either of the presenters? And thank you both for all of your information. Yes, and anything that you have to share with the participants, please send them my way and I'll pass them on to Erica. So any other questions or any other information you want to know from the presenters?
Well, I saw a question about students' reaction to the extra fee. I really don't think that they notice. There's so many other fees applied in there that I've never had a student question me on why they have that extra fee.
At Southeast, our students actually pay less for this cohorted course than they would if they took intermediate algebra followed by college algebra. So they pay for 5 hours instead of 6 hours. And our other courses that are all co-rect, all of the statistics and the mathematical reasoning and the math for education, those courses are a 3-credit course and then only a 1-credit developmental they have to pay for. So it's much less than what they would have paid for in our old system, which had layers of developmental, kind of similar to what Lance was showing. Sorry, that's my clock.
You have a singing clock? That's nice.
It was a Lifetime Achievement Award when I was 40, so I don't know what happened after that. I expect it's going downhill quickly.
Okay, so here's the contact information. You feel free to send any information or any questions to me and I can direct it to the right person. And then you have Lance and Dan and Tammy's direct contact information here as well. Erica, do you have any other last minute comments? This recording will be shared for Erica to post on y'all's website for participants to go back and listen to and share with others. So any last minute comments you would like to share with the group?
I think just, reminding everyone we'll be posting this and sending this out. Also, we would love it if the presenters would be willing to share your syllabus. I think showing those examples would be really helpful for folks as they're reviewing the webinar to see what you've done. And also just to also reiterate what Paula said, thank you so much. This was really informative. It's exactly what people have been asking for. And I know our attendance was a little bit lower today, but I also know it's, as you know, faculty are often teaching right now. So we do tend to get a lot of folks that look at our information online too. So thank you all very much.
Okay, well, thank you, everyone. I hope you have a wonderful rest of your Monday and a great week. And we'll see some of you on the line again next week.